Good afternoon and welcome to the first CS 526 seminar, CERIAS seminar of the semester. I'm Gene Spafford and I'm doing the intro to the course today. The instructor for this course for this semester, Professor Maji of CS, is out of the country, so he can't do it today. I'm standing in for him. If you haven't participated in these before, let me just give you, for those of you in the room who are enrolled in the class, a little bit of background. This is a 4-credit course that you can sign up for. If you have signed up for this course, each week you need to sign in on the sign-in sheet, which is circulating in the room, and record that you're here. The class is a pass-fail class. It's based on your attendance. If you miss more than 2 of the presentations, then you'll need to do a makeup, and Professor Maji is the one who will provide that. For the course itself, we're going to have a variety of speakers this semester, as with every semester, and you get to listen to their presentation. At the end of the presentation, if they're willing to take questions, or during the presentation take questions, you need to turn on the microphone in front of you at the table, and you do that by pressing the little button until the green light goes on. That's not so that the presenter can hear you, but so that we can capture your question on the video. These are recorded and then made available through iTunes, through YouTube, and on the CERIAS website, so you can go back and look at these later, should you wish. And there are many people who view the seminar remotely, and to those people, welcome also. We're glad to have you listening in. Let me ask that if you're in the room, please turn your cell phones off or mute the ringer during the presentation as a courtesy to the guest. And I'll use that as a segue. Our guest today is Michael Taylor. He is the Chief Software Developer at Rook Consulting. Rook is a major software and security vendor here in Indiana, is a partner with CERIAS, and does a lot of work, well, not just in Indiana, actually. It's throughout the country and beyond. But they're based here in Indiana, in Indianapolis, and they do a lot of work in development of software in response and consulting. And Michael has been their lead developer for a number of years, and he's going to talk to us today about methods for developing secure and perhaps insecure software. So, Michael, thank you very much for joining us.
Thank you. Hello, Michael Taylor. So just a little bit of background on me and what we do at Rook Security. So we're a managed security service provider. So we basically monitor and walk the perimeter of our clients' networks, looking for intrusions and the signs of compromise within the client's environments. I was brought in about 3 years ago because as we were growing, it was the need was identified that we needed to better integrate with the various deployments within our clients' environment. So some clients would have, say, Palo Alto firewalls, other ones would have SonicWall, other ones would have one set of SIEM solution, and we needed a way to better integrate and automate that process. And so we started the development team about 3 years ago, and we've since deployed our tools in Fortune 100, Fortune 500 clients everywhere from China to India, as well as locally. I did my undergrad at WGU. I also teach secure code at the 1150 Academy. That's down in Indianapolis. They focus on app development and kind of job transition seekers to get people from zero to being able to program fairly quickly. I enjoy D&D, other board games, online video games, as I'm sure many of you do. So the general focus for this is going to be the patterns that we see in secure development and the practices that we've seen to be successful in development environments, the things that we've identified as yielding net positives for those teams, and then the things that are seen to be net negatives, things that the anti-patterns, the things that companies repeatedly do thinking that they're going to have a good outcome, but in fact they have a terrible outcome in many cases. So just from the top, the security by design is often something that is neglected at the beginning of the requirements gathering, not planning your project in a secure manner, not spending the cycles at the beginning to ensure that the way you're going to implement your solution from the bare wire to the graphical user interface is designed securely. And then looking at those aspects both in the development of the code as well as in the deployment of that code, whether it's on a mobile device or up in the cloud. Security training is another aspect that we like to focus on. One of the issues that we see with a lot of the interviewees that we look at is that they often haven't either had security training within their undergrad, or that it came so late in their career that they've developed bad habits in the way they approach code and the way they think about code. And so whether it's failure to address input sanitization as a default kind of practice, or whether it's looking at the way that they design their classes and their architecture, that's something that is kind of a bad habit that we like to try to break with the secure training that we provide. And then employee awareness. Most of the breaches that you've heard about, everywhere from Target to Home Depot and Jimmy John's, often have a social engineering component. So looking at how to ensure that your end users and your employees are being trained in the way to approach security is just as important as ensuring that your code is secure. And then just to revisit the solid principles of development, for object-oriented development is usually a good refresher, since just like with the revisiting the best practices to ensure that you're kind of truing up with what you're currently doing and how we've seen the best way to do that. Oops. And then the anti-patterns, these are certainly not all encompassing. These are just a few that I chose to address. These are things that we've seen in deployments when we do our pen testing, as well as our code review, that we've seen in companies everywhere from the startups to Fortune 100 companies, where they are have not invested to pay off the technical debt into ensuring that they have followed the best practices. And so they can be called anti-patterns. Also code smells, like your fish has gone bad, your code smells. So it's not a matter of if your application is going to be attacked, it's really a matter of when these days. Whether you are just getting a drive-by from somebody who sees your application out on the web and they decide to try and pop it, or you're a victim of a targeted attack, it really is if the case where if you have a service out on the internet, somebody is going to see it and somebody is going to attempt to pop it, either through the programmatic methods using like Metasploit or Nessus or something along those lines, or if they perceive that you have something high value and then really investing the time to go after it. Some of the trends in that space is the transition from attacking credit card companies or companies who hold credit card data to the healthcare industry, because the healthcare records are much more rich in the information about the individual that they have And so instead of just having a credit card entry, they can do loan applications and a variety of other financial instruments that, based on that data, that you wouldn't otherwise be able to do just from getting the credit card information. So, security by design. You want to make sure that the way you're designing your system is not just accidentally preventing an attacker from being able to get into your system, but that you are intentionally designing your system securely in a manner that will not only address the current known attacks that you have identified, but allow you to address future ones and be flexible enough that you can do that without incurring a significant amount of resources being spent to do that. So when you're selecting your the way you're going to architect your system, looking at whether you want to use an open source operating system versus a closed source operating system, whether you want to use something like Amazon's Lambda processing, stream processing, instead of having to host your own operating systems to run your code. Those are considerations to take into account. One of the things that we see as well during our code analysis is that not the considerations and the libraries that are used and imported, whether they are third-party or built in-house or open source, they're making sure that you're going to be able to rely on those libraries now and in the future to be supported is important, and making the decision as to whether for your use case, is it appropriate to use an open source library, or is it the better choice to use to redevelop it in-house so that you can ensure the appropriate maintenance of that library. And within the development world, as I mentioned, it's not always the code that's being attacked. A lot of times it can be other components, from social engineering to your network. And so your code may be secure, but if your network is not, then all the sanitization and error checking is not going to prevent your system from being compromised. So we found that it's been beneficial for developers to have some basic understandings of the operating system and the networks and things like that, so that they can be a more contribute more to the team during the design decisions, and troubleshoot their own problems and understand how their application is actually being built and deployed without being kind of constrained to their IDE, where they're siloed off in just the code. It's better, in our opinion, that they have a more well-rounded knowledge of how the system is put together. So, excuse me. So Carnegie Mellon's capability maturity model integration defines a series of security regions where you can make these decisions. So from the security process area to the development process, the products and solutions, and process assets. This workflow helps to ensure that you're at each stage of your decision-making process, that you are preparing yourself for a secure solution. So and this also ensures that you're able to continue to follow the various regulatory bodies guidelines. So everything from the Sarbanes-Oxley Act to the PCI DSS for your credit cards to HIPAA, designing your system to have these decision-making gates in place allows your team to continue to develop securely. So here's the workflow from Carnegie Mellon. And so from the top down, you can see you're looking at your organizational preparedness for your software development. So how well is your current network and infrastructure designed? Do you have your virtual private cloud implemented in such a manner that you can segment off from your publicly facing to your development environment to your staging and QA, your security management and projects? So are you investing the appropriate amount of resources in designing and testing your systems, your requirements and technical solutions, ensuring that your system is, or your design process is including security as a component. One of the major downfalls we see is security being not a value add to a system. Security can often be dropped as unnecessary in favor of focusing on features. And if your management team is not buying into security and they say, you know, give me 2 features instead of implementing security appropriately, that can be a problem. I'm not going to focus too much more on this, but this is, you know, an example of how organizationally it's important to establish security as an integral part of the way your development team and your network team and your operations team plan to implement security within your platform and in the future as you deploy it to your clients. So some of the other criteria that you need to look at is how are you managing your source? You know, do all of your developers have you know, read-write to your repositories? Do you have appropriate segmentation within your projects? The risk being you have a developer leave your organization, they had read to all of your repositories. Now perhaps your information and your code is out in the wild. What deployment tools are you using? So how are you getting your code from Git or Bitbucket or SVN and out and onto your servers? Are you storing keys out in your servers that might be compromised to later access your code? Those types of design decisions have to be made at a higher level than just within your code base. You have to choose the tools that allow you to do that type of process. You have to make sure that those tools integrate with the environment that you're planning to deploy onto. Your continuous integration system is also important. Being able to identify bugs within your system and quickly address them and push patches is highly important. If you remember the heartbleed or shell shock bugs that we've seen in the past, being able to identify that you're vulnerable to that library and then quickly mitigate and then patch as those become available was an important step for many companies who are vulnerable to that, to not being compromised. And because you know, it's very easy to identify somebody's running Apache, they're running Apache on a Linux server, and therefore they're vulnerable to this, and an attacker try to pop them. Your unit tests and code coverage, that's another thing that can often be dropped by the wayside during your application development. With the reasoning being management wants more features. Management will want you know, the next revision to be released, and the things like code coverage or unit testing are often seen as extraneous. And if you don't enforce strong compliance to your company's security policies and processes, then those can be neglected, and then you have a greater and greater technical debt that you'll eventually have to either address or pay off in some manner when you get to it. Penetration testing and the static code analysis is another component. Getting third-party eyes on your code from outside developers is a really useful thing to finding and identifying the ways in which your code is potentially vulnerable. never trust your users, whether it's a cat walking across your keyboard or somebody maliciously trying to attack your system. It can often take somebody from who wasn't deep in the design to identify the way that your system might be broken. Network segmentation, is also a key component. You don't want your developers working in production. That always ends in tears. And so, as much as your developers might want to be able to say, well, there's just a problem out in production, I'll do a quick, bug fix. Following your appropriate code deployment procedures will ensure that your production environment doesn't stray out of alignment with the appropriate configuration that you've established for that environment. And then having your staging and quality assurance environments also segmented so that your development data and staging data, testing data doesn't get pushed into production, and that those systems aren't a vector of attack against your client and production data. You don't want somebody coming into a potentially insecure development box and being able to use that as a jump host into your production environment. So employee training is, in my mind, almost as important as development training. Your secretary or HR resource that has access to everybody's records, especially the financial suite. We've seen CFOs and vice presidents of finance be targeted for wire fraud transfers fairly frequently. And that's because executives are a target-rich environment from an attacker's perspective. It takes a relatively low level of effort to attack them because typically it's a spear phishing campaign where they've identified the bank that a company may use. They create a fraudulent email to address a CFO or a SVP of finance. They say, wire transfer me $20,000. It's a Tuesday. The executive's expecting a series of wire transfer requests. They click the button and the money's gone. And this is because the executives don't typically have the same expertise with security as other members of the company, and they're also more prone to break the rules because they are executives and they have fewer people to report to. So they're particularly prone to that type of attack. Password management policies, nobody likes changing their password. Nobody likes having to remember highly complex passwords. But there are tools these days that can make that much easier. Things like LastPass or KeePass allow you to programmatically change your passwords, generate highly complex and secure passwords, as well as being able to access them remotely, so you're not having to keep a password database with you. And then applying those policies from a corporate level is one way to ensure that you're not having people have a post-it note with their master password right on their laptop. Other things like ubi keys to add a salt to your password. So you might have a relatively simple password like baseball, horses, but then your ubi key allows you to inject a complex series of additional characters to that password each time you need to enter it. Can allow you to heighten your password complexity without having to increase the difficulty at remembering it. The social engineering awareness, one of the things that we do is physical testing. This is where we go on site and we see how far into a corporate environment can we get before somebody stops us, and what can we do there. So it's usually just a polo and a clipboard, and I'm Michael from your IT servicing company. I need to go check your network closet. And many times they will let us right in without having any kind of scheduled appointment, and then it's, oh, well, I'm in your network closet, and it looks like I need a password to reset your email access. Oh, okay. Well, I've already let you in the door. You're already in the network closet. Go for it. And so having your employees have the appropriate amount of training is really important. Because like I said, it doesn't matter if you deployed your code securely. It doesn't matter if you wrote your code securely. If you have an attacker physically present in your network closet, it's essentially game over at that point. They can install pony boxes, they can install network sniffers, they can hard reset your firewalls. The number of vectors of attack that they have once they have a physical presence in your environment is essentially unlimited. And so that first person at the door, whether it's a secretary or whoever's controlling entry, is just as important as your application developer or network architect. And that kind of transitions to the bring your own device situation, where people are bringing in their own cell phones, bringing in their own laptops to work. Well, as I'm sure you've seen, cell phones are a great vector to get at personally identifiable information and passwords. You install Candy Crush Saga 2.0 and they decide to release that into malware. There have been now libraries allowing you to root a phone through the updates, and so now Candy Crush has rooted your phone and it's listening to the passwords that your phone's sending to Gmail or whatever other services that you're connected to on the corporate network, and that's yet another vector of attack. If you're using your corporate laptop, for example, in your home network, if your home network's insecure, that can also be a way attackers can target you. So if you're bringing your corporate laptop, logging into your corporate email, and you're advertising your home Wi-Fi with default passwords and default SSIDs, it's relatively easy to attack you from that vector. So some relatively easy training from an employee standpoint can go a long way into protecting your PI and PII data. So any questions thus far about anything that I've covered? No? All right. So solid principles. So solid design principles are object-oriented ideas that we have found it's important to include when you're writing your code as well as when you're designing it. And so just briefly, single responsibility principle, the open-close principle, Liskov substitution, interface segregation, and dependency inversion. And so the reason these are important to security and not just design is it allows you to ensure that when you're developing in an object-oriented environment, that if you follow these principles, that you're not exposing yourself inadvertently to vectors of attack. And each of these principles helps to encourage you to develop securely, whether it's intentionally secure or not. It makes your code more modular. It allows you to have lower technical debt when you're extending your code. And it also allows you to extend and your development process more quickly. Like I mentioned, having some network fundamentals within your development team, so that as you're developing, if a service is unavailable, your developer is not not beholden to the network team to tell you, well, that server's down. Having some basic understanding of how to get to how to identify what ports an external server is listening to, how to identify whether your SSL keys are valid or not for the service that you're trying to get to, and things like that can limit the downtime of a developer as they're working, because they can be their own help desk rather than relying on an external team. And then following the least privilege model. So if we go back to the Heartbleed attack, if your Apache server is running as root, or shell shock rather, if your Apache server is running as root, if you pop Apache, all of a sudden you have root on that box rather than if you were running as a limited service account, then you're exposed much less than you might otherwise be. And then, you know, there are many other different design principles, you know, everything from continuing education to stress testing and load balancing. One of the interesting things that we've seen as cloud deployments have become more popular is stress testing a system to the point where it starts to fail over or add resources can change the topology and attack surface of a system. And so if you can force it to fail over to its non-standard state, you can expose systems that are more vulnerable than the one that you were attacking initially. The single responsibility principle, classes should have only one reason to change. Now, this is important because a class should have only a business principle behind it for its change. It shouldn't be changing at the behest of anything outside of that single principle. So a great example is the engine in your car. So to most of us, when we turn on our car, we don't care whether it's a V8 or it's an electric engine or whatever. We just care that it's powering our wheels. But to a mechanic who's trying to service your engine, it's going to be greatly important as to whether it's a Nissan V6 or a Toyota V8 and what the individual components are. And so understanding that the only reason that from the user's perspective, that engine should change is for your perspective. So the mechanic has a different use case than the end user. And so, you know, why not have just a single purpose for your objects would be, you would end up with not a one-to-one relationship between objects and methods. And that would be not an ideal situation because of, you know, code overhead and design cumbersomeness. So the open-close principle. So objects should be open for extension, but closed for modification. And so if I like the shape example here, so if I had a shape object and I needed to calculate the area of a shape, it would be better for me to have within the shape a method to return the area instead of me inferring that this shape's a square, so then I will get the area by multiplying the shape side by the shape side, and this area is a circle, and I'll multiply it by pi times the radius squared. It would be, this allows you to extend that class much more easily than you might otherwise do. Liskov substitution principle. Return to the shape example. You know, all squares are rectangles, but not all rectangles are squares. So if you had the rectangle be the parent of the square object, you can run into issues where you're trying to set the side of a square object, and you're having to overwrite your methods to ensure that for the square object, both sides are being set rather than setting the, you know, say, width and height individually. And so if you do that, you'll violate this particular principle. And so it's better to implement the generalized shaped object with its own area method rather than using that inheritance for the rectangle. And so interface segregation. Clients should not be forced to create methods that they don't use. We see this in a lot of our front-end development where if you're trying to use a login method, sometimes certain frameworks will make you follow a series of steps that aren't necessary to, say, just display a web portal, rather than allowing you to segment a login page to a table of contents, etc. So you shouldn't force an object to implement methods that aren't necessary. And the shape analogy comes back to haunt us, where if we have a square object, we shouldn't force it to have a volume method, because it's a 2D shape. There's no concept of volume to that. So implementing a solid shape object, which could then have the volume contract as a component, would make more sense in this scenario. Dependency inversion. So I enjoy this quote from Derek. So high-level modules should not depend on lower-level modules. Both should depend on abstractions. Abstractions should not depend on details. Details should depend on abstractions. And so essentially what he's saying is to correctly bind your system together, it's important to not depend on the details of the higher-level abstractions and not the other way around. So this has to do with the idea of coupling and how tightly coupled your system is together. So an example here, if you have an API that's implemented for a web application, the consumer shouldn't know if I decide to change it entirely from being written in .NET to written in Python. I should be able to, as long as what you're receiving from me from a API perspective remains the same, as long as you're receiving the same data structure, it shouldn't matter to the consumer. Network fundamentals, we mentioned a little bit, in helping the developers not only troubleshoot their own code, but to allow them to contribute more to the design and architecture of the projects that they're working on, and having that more generalized knowledge of the way systems work, and ensuring that they understand how the components tie together can not only give them a better ability to contribute, but a better ability to troubleshoot their own problems. So problems that I've seen where we've managed external development teams, like in the Asia Pacific region, where they're less well-rounded. The pace at which they can develop code is limited because they don't have the network understanding that they need to be able to understand why they can't reach the services that they're trying to get to, or why they aren't crafting their SSL certificates appropriately to be validated within the environment that they're working with. And so ensuring that your developers have a general understanding of how to do these things really improves the productivity. Least privilege design. This is a scenario where the level of access and the privileges that a user or service has can either increase or decrease the risk at which you are presented as you're offering your service. So making sure that you're everywhere from your code repositories, where users should be limited in the number of repositories that they can see, to your service level accounts, where your services should have a limited account running the service, so that if it's exposed or compromised, it's not able to compromise the entire system. This also goes into the way you write your code. Your procedures and your methods should have a limited scope at which they can modify and access data. We see this with private or protected methods, as well as with the inheritance policy of certain methods. and this helps improve system stability and allows you to deploy more easily. If you have to run your deployment code as root every time, that's often a sign that you're not deploying things as well as you might otherwise, and clearly it will help improve your system security. So we get on into the anti-patterns and the code smells. So these are the things that we see that people continue to implement, even though it is it causes them pain and heartache. And so Henry Spencer has stated, "Those who do not understand the Unix platform are condemned to reinvent it, albeit poorly." And we see this a lot. People need a scheduler. Instead of using cron, they invent their own. People need an email system. Instead of using the SMTP processes that or services that are built into Unix, they write their own to interface with that. And not only is that bad practice because there's already a service available for them to use, but now they have the additional technical debt of having to support the code that they wrote. And now they're responsible for any bugs that are in that code. They're responsible for updates and additional features instead of relying on the people who came before them and have been, likely working on that particular problem set much longer than they have. And we see this in relatively inexperienced development teams. As the team grows in maturity, these mistakes typically lessen, but they can often carry on throughout a project where a design mistake early on, as the team was relatively young, can be persistent within that code base. And so, additional scope and reliance on that redundant system that they designed can often be pushed forward through multiple releases. And this is particularly bad practice because it's not productive. You're not getting any more features into your product. Your development team is often working outside of their field of expertise, and so you're making increasingly expensive mistakes. But in certain circumstances, it is important to do it yourself. If there's a library that's open source but has a particularly restrictive license, you might need to rewrite that library for your own internal development if you're not allowed to then resell the code, or if you have to follow certain attribution or release code. That might be one reason why you might rewrite an entire system, but it's a very fine line in making that decision. The God object. So often this starts off as a relatively naive object. You write a manager object that's going to do a couple things, and all of a sudden that object is responsible for the rising of the sun and the setting of the moon, and you can't get away from calling it in one way or another to do everything within your system. And so, whether it's getting inherited by everything or it's carrying out more responsibilities, it's violating the single responsibility principle. And we see this sometimes with front ends where your API server is running just one massive behemoth of a code stack to return a database interface that might otherwise be able to be implemented elegantly with a different platform, or you're running an engine that is managing all the starting and stopping of your processes. You're for back to our email example, it's reading everybody's inbox and tagging it and filtering it, and instead of having a set of more modular code. Another example, the ghost object or the poltergeist object. We see this where more procedurally experienced developers become object-oriented developers, and they perhaps aren't as knowledgeable about how to work within object-oriented design. So they might create an object that is a shim in their code to start up a class and set some things, and then that object goes away. And this is a problem because it introduces artificial complexity in the system, and it's cumbersome to maintain, as well as share the knowledge within your development team. That knowledge transfer of, I need to call, server object init 0 and then wait, and then server object init 10 later is not at all object oriented. It follows a more procedural design pattern, and that's it's not only inefficient, but it makes it difficult for the onboarding of new developers and the documentation of your code as you move forward. Another one, missing abstraction. So, if you have, say, hard-coded user account information or network information as an inheritable file, that can, instead of having that in an object or a configuration method, this can break your deployment. Say I deployed out in Amazon and I had a public IP, and I hard-coded that public IP instead of obtaining that either from an if config or some other statement. Now my service isn't going to work because it's expecting one IP when my server is currently existing at another location. This can happen anywhere from global variables to usernames and things like that. So this is an interesting one. So the over or under emphasis on security. So like I mentioned before, security isn't a value add to most products. It's assumed that if I'm using an email app, that it's going to be secure. If I'm using Pokemon Go, it's not going to compromise my Gmail account. But in reality, security is adding value, because if you don't have security and you become compromised, your company very well may go under. But it's an inferred value. So if you push it off until later and later and later and never address it, you have an almost insurmountable amount of technical debt that you have to in one big bite address. Or if you focus on it all too much before your application is mature, you can really limit the growth of your application. And so it's important to be able to identify at what level of maturity is your application. Are you obtaining client data, or are you just working with your test data? And are you preparing to begin ingesting client data, at which point you really do need to be prepared to protect that. And so understanding when to emphasize it and having the appropriate decision gates within your development process will ensure that you're not hampering your overall development progress. And often it's underemphasis, as I mentioned before, because features are often seen as more valuable than security. Security silos, we see this often in larger organizations, where instead of a smaller development or DevOps team, you have IT ops and help desk and the networking team, and then the developers. And so having an unclear delegation of duties, as to who's responsible for the network security and who's responsible for the network architecture, and then who's responsible for the code security. If that is all somewhat muddled and each of those teams reports to different managers, then there can be infighting and other friction within the organization that creates inefficiencies. And that type of friction can lead to power plays and people getting pushed out. Another scenario that we see is in CISOs and CIOs who frequently don't last more than 2 years in an organization. They get golden parachutes and they move on to the next stepping stone. And a common pattern is they enter an organization, they say, oh, I see you've got this finite set of problems. I'm going to fix it by purchasing XYZ piece of software. By the time that software is getting installed and implemented corporate-wide, they're exiting before they even see whether that solution was the right solution or addressed any of the initial problems that they were brought in for. And if you have your teams being segmented, that creates even more confusion as to who is ultimately responsible for that decision, who's going to now carry on that that process that the now exiting C-level executive has created. And that is all. Can I answer any questions, or you guys?
So there's a lot of
Push your button.
So this may be too hard to do block question, but when you take a look at most of the clients that you see, where would you find most, how would you allocate between training, development, and just the normal staff in terms of vulnerabilities?
Where do the vulnerabilities arise the most?
You had to suddenly say, I'm going to try to fix the worst thing first. Where does it most likely happen?
I would say it almost has to be in training. We're just looking at a response where some of the pen testing organizations will say, if I have a 80% success rate with a phishing campaign, that means 2 out of my 10 employees failed to follow the best practices when reacting to a spear phishing campaign. That's a successful set of training. To me, that's a highly problematic metric to follow. If especially given that if you have like a shared set of network drives, that's BitLocker on those network drives. If one of those 2 people who failed was a HR secretary, that's your entire employee set of records now gone. I think that the training there in many organizations is where the softest component is, because it's not requiring the attackers to find a break in your code. They don't have to understand your database schema or the vulnerabilities in your API. All they have to do is manipulate the person. And I think that is ultimately the most cost-effective way for an attacker to gain access to your system. And attackers, those groups are run like businesses. They follow the SCLC, they have managers, they have features, they have deployment strategies. So that they are in the same way the privately run organizations are operated. They have revenue goals, and the cheapest way to get money is going to be the way that they're often going to try to achieve that goal. I'm sorry?
Nobody else? I have one question. Do you get to do kind of repeat inspections into things, and do you find, is training effective? Is it, or are there things that seem to make a big impact? Are there things that don't seem to have an impact?
Yeah, sure. So we'll frequently, organizations will have periodic testing that's required from either PCI or HIPAA or one of the other regulatory bodies requires them to on a certain time frame do this either training or testing. And what we've seen is you might do spearphishing training and say, look at the URL from which your email is coming before you click a download, and ensure that you're expecting an attachment before you download it and things like that. And kind of like an immunization, you see an improvement and then you see a fall off. And so we'll do the kind of testing where immediately after the training we see how well people are doing, and then a lot of times that's announced testing where we'll say, okay, you guys just all did the training, now we're going to do a spearphishing campaign. And so they're aware of it, and then maybe a month later do an unannounced campaign, and that's typically much less, the success rate of the campaign is much higher from the attacker's perspective.
I mean, how close does it get to the starting point? Is there really a long-term benefit to the training that you see?
So there is. It's incremental though. It's the non-technically adept individuals. It's about repetition and in the same way that everybody learns, repetition and encouragement, and showing them how this improvement is protecting not only their jobs but the organization's profitability, is how we often see that improvement go through. But there's no silver bullet to say one magical training solution gets everybody on board, or one network pen test all of a sudden has captured all of the vulnerabilities in your environment, and you do a round of fixing, and then the next time we come in, nothing's there. Because there's only so many hours and that an organization can invest. And so we, like for the network pen tests, we'll do one series and they fix maybe they fix all the criticals, but then we still have all the highs and mediums and lows that they have to address, and those are often a value judgment versus it's not like saying a critical vulnerability is 32 degrees Celsius and a high vulnerability is 40 degrees Celsius. A lot of times it's about what is of value on that asset. Is it a development machine, or is it in production? Is it holding PII data, or is it not? And so making sure that as you're running those tests, you're aware of what's at risk allows us to increase or decrease those thresholds.
Do we have any other questions?
Yeah.
When you look at some of the software development that's going out there, are you seeing software developers starting to utilize some of the APIs that are out there for like operating systems? I mean, we've seen a lot of improvement with like, trusted platforms, hardware security, enclaves, but these seem to be separate APIs that you have to use. So, I'm sure people are doing better with web application development in terms of using, APIs for SSL, TLS, but there's a lot of the underlining APIs,
Right.
Are you seeing a lot of that, or, I mean, how's the training with that, and is that a part of do you see that being adopted, or?
So it really depends on the organization's core business model, and as to how much that's being emphasized in their development process. GE's CEO just said that every new hire that they have moving forward is going to learn how to program in one way, shape, or form. And we see this frequently with amateur developers who are really wanting to teach themselves how to code, and so they're writing a web app and releasing it out into the store, and then that's on your phone that is with you everywhere that you go. And so this kind of there's today there's a much wider range and the experience level and expertise of developers than I think there has ever been. You know, when, you know, even a decade ago, most code was written more predominantly by professionals than it is now. And so those security APIs and the operating system components that are available now are not necessarily being adopted by those amateurs who have not been exposed to security from the beginning of their development careers. They've been hobbyists or you know, tangentially exposed to programming and are, you know, self-taught rather than getting that understanding of how to develop securely from the beginning of their career.
I'd like to thank Mr. Taylor for his presentation and discussion here.
Thank you.